I think it's oh no, I don't think the device audio is capturing here. Then it's fine. Um, has someone caught fever or something? Mr. Bandar is there, right? So, uh, right. So, Mr. Bandar, good morning. So, shall we? Yes. Shall we mute the mic for some time because I'm recording this lecture. That's why. So immediately after I stop the recording, you can turn on the mic and we'll answer for the questions. Right. Okay. Thank you. Right. So just see this slide. I will explain it. I will give you the provide you the clarifications at the end. All right. So let's start the recording. Operating systems. So first, why we need an operating system? Can you remember? So in the last sessions, we have discussed about computer hardware. So in that case, computer has the hardware, software, and liveware. So hardware can't be controlled by us. We can't control the hardware directly. So in that case, we need software. So software will give instructions to hardware and we can program or we can give instructions to the hardware through the software. So softwares are going to be a communicator between the hardware and the liveware. Liveware in the sense us, in this case me. And there's another problem. Software, we have two types. Software, we have two types of software. Software, we have two types. The operating system or system software and the application software. System software and the application software. So we have learned about these things. System software in the sense, system software is totally operating systems. So why we have operating systems? We have operating systems to control the hardware. We have operating systems to control the hardware. And we have the application softwares to do certain processes. System software, we have it to directly control the hardware like Windows 10, Windows 11, Linux, Mac OS, Android, likewise. And when it comes to the application software, we have Excel, Word, PowerPoint, and other softwares, Photoshop. So application software has limited capabilities. It is only for one purpose. But when it comes to the system software, we have the operating systems and the device drivers. Operating system is the most intelligent thing and it can handle thousands, millions of tasks in the background. Millions of tasks in the background. So we'll see a modern computer consists of one or more processors, main memory, disks, printers, various input output devices. So I will show you what are the processors and other things exist in my computer. So how to see that? So you can just go here. So let me zoom in. You can press Windows plus button to zoom in your computer. Windows key. So this is for your knowledge. Windows key plus the plus button to zoom. Right, so let me show you. So here it's already zoomed here. This one. So it's the magnifier, right? Windows key plus plus, Windows and plus. Here you can see the magnifier. If I press again, it's going to zoom. So that's how you zoom in and zoom out in Windows. Right. So let me pay your attention for here. Start, right click, and you can go to Task Manager. Task Manager. So now we are going to discover how important our operating system is. So here you have processors. Are you aware about these things? Some things? No. Here, Brave browser is running. I'm aware about that. Microsoft Edge is running. Are we aware about that? Screen Magnifier is running. Okay, I have opened it. OBS Studio, Task Manager, WhatsApp, Windows Explorer. But how about these things? Are you aware about these things? Here, we have 106 background processes. But if you see here, I only see 1, 2, 3, 4, 5, 6, 7. 7 apps. But in the background, here, the calculator is also running. Calculator is also running in the background. So let me stop it. You can right click and press enter. Then it will stop. But here we have some updates also here. So Creative Cloud, in the sense it's something related to Photoshop, Adobe Suite. And here also we have several updates, maybe some other things in the background processes. Here several. And Windows processes 111. So secretly Windows is doing its job. It is not letting us to know those things. It's secretly doing those things. Interesting. Do you think it's that all? No, that's not all. Here, if you go to the services, these are processes and these are services. Two different things. So here also we have thousands, 10,000s of services. And think about this PID. PID means process ID. Here we have 10,460. So there may be 10,459 even. It says here 13,556 here. So it's then now you can understand how important is the operating system. It's doing a great work. It's doing a heavy task. Right. So that's about the services and processes. Then what is about this? One or more processors. One or more processors. So let's see. Can we see how many processors are in my computer? So you can try yours also. In the meantime, so go to the task manager. You know how to go, and go to performance. This one, performance tab, and here there you go. Here you have the CPU, memory, some groups. So CPU is the thing we are looking for. CPU where we have cores. So here I have two cores, dual core, and this is the speed, right? That's it. And these are some these are like cache in the sense these are like registers. So two cores, dual core. And what about the other things? Main memory means it's RAM. Main memory means the RAM. We have discussed this. So how to see the RAM? Here they have a dedicated tab. Memory 11 GB. So if you click here, you can see the graph, and here you can see the how many slots are there. So I have two slots, 4 GB slot, 8 GB slot, altogether 12 GB. And here it is form this one, and speed 2.1 gigahertz, megahertz divided by 1000 gigahertz. So here we have altogether 20 GB. And what about the disks? Disks in the sense memory, hard disk or SSD, HDD or SSD. So how to see that one? It is here. Here, disk 1, 0% is used. 0% is used in the sense reading writing speed. It's not reading anything from the C drive. It's in the idle position. So capacity, here we have it's 128. So 112 is available. 16 gigabytes is for the operating system. System disk, yes, SSD, type SSD. So if you go to this one, disk, you can see here disk size, hard disk E also not using. It has 1 TB, 932 free. It is a hard disk. Hard disk. Read speed, write speed, nothing is reading or nothing is writing. And here you have some other speeds also. Wi-Fi speed. Here now it's showing my router, signal strength, IP address. So here you can see the graph and other things also. Here we have the GPU, two GPUs. GPU means graphical processor unit, graphical processing unit. Why is there? For these things. Here video processing. When I finish recording this one, so here I am using the OBS Studio, it's real time recording. So finish this one to render this one. Render in the sense to save this one, I need a GPU. Otherwise, it will take hours. But here, no, just seconds because of this GPUs. Because I have GPUs, and the second one also. Right. So GPU power. Here you can see GPU 0 or 1 is 6 GB, and the second one is it's around 2 GB. 2 GB. So altogether 8 GB. 8 GB. Here CPU memory 6, and here I have it around 14 GB GPU, and that's it, right? Then you have other tabs also, users likewise. Uh, those are not totally relevant for us. I hope you understand it. So here can you see OBS Studio is using GPU. Why is that? Because yeah, it's using GPU. Why is that? Because it's a graphical software. It needs GPU power. If you expand, you can see. Right. So that's about a quick overview, and here you can see the network also. OBS is not using any network, but Brave is using. Why is that? Because I'm connected to Google Meet. Yeah. Memory is also using. So if you go to the Microsoft Edge, that is using lecture note 3. This one is using 65.9 MBs from my memory. Lecture note 3. Why? I haven't saved it. So if I save, what will happen? Let's see. Let me take it like this and like this. So here this it is not saved, right? 66.4. Let me save it, right? So I'm going to click somewhere here and escape. I'm going to save, right? Once I save, what has happened? It's declining now. It's declining now, right? So if I close this and again open the task manager, it's going to decline, right? I think you got my point, because otherwise you will think it doesn't make any sense. So let me show you, right? So here it's loading, and Windows Explorer, Windows, no, Windows Explorer Edge. All right. So here it's declined. Previously it was 68 something. Now it's 67. Why is that? Because I have saved the PDF, right? So without diving deep more, let's continue. So what about the printers? So if you have connected a printer, it's output device, various input and output devices. So you can be with the device manager. So how to use that one? Go to start, just hover, right click and select the device manager. Device manager. Then in this device manager, if you maximize it, so it will take some time. Sometimes it's going to stuck, right? Here you have all the devices listed. Audio input and outputs. Let me check my headphone is there. This one is my headphone. This one. Batteries, it's also there. I have some battery. Bluetooth, it's working. Camera, one camera. Computer, only one computer, right? And disk drivers, this is HDD, this is SSD. All the things are there. Display adapters, only one. If I connect, this is GPUs. If I connect multiple monitors and stuff, you will see. Here you have USB ports, keyboards only one, mouse two mouse. This is the inbuilt one. This is one is the touchpad. Monitors one. Network adapters instance, Wi-Fi card, Ethernet. We have several, and printer nothing. Printer nothing. No printers. These are not actually printers. Processors here listed the same one. Sensors, Visual Studio, location simulator sensor, some sensor is there. Sound again, those things. And USBs here. USBs, I have around 4 USB ports. Right. So then you have learned about how to see your input output devices and the processors and the memory. Alright, let's continue. Writing programs that keep track of all these components and use them correctly alone is a difficult job. It's true. How many devices were there? There were thousands, hundreds. Can we control these things individually? No, not possible. It's not possible. It's a tiring task, right? It's not possible. So, for this reason, computers are equipped with a layer of software called operating system. An operating system is a program that acts as an interface, so I have mentioned, between the user and the computer hardware and controls the execution of all kinds of programs. So it is acting as a translator or a third party between the hardware and the user, because the user can't give direct instructions for the hardware, and the hardware can't communicate, or hardware can't understand what is meant by the user. So user is saying print, but hardware won't understand this. And also hardware is sensitive to machine language. And here we have a graphical representation. What is an operating system? So here hardware is there. And we have the user mode in the sense, user is here, user is giving some things here, and these two layers are hardware, two different hardwares. This one is application software. User mode is web browser. It's accessible by the user, and there you have the user interface. That's correct. Then operating system, we called it as the kernel. Another name for operating system, kernel. And operating system is going to work with the hardware. So here this is more clear. User is somewhere here. User mode in the sense user can interact with these web browsers, softwares, and user interfaces. Then user will provide instructions to the application. Application will communicate with the operating system. Operating system is going to work with the hardware. This happens reverse. If the hardware has something to communicate with the user, it will provide the data to operating system to the application interface, user interface. Through it, user can get the information. What is an operating system further? Examples: Windows, Linux, Mac, Android. Mac is there. Then what? Android. The new Huawei Harmony OS, newest one, Huawei Harmony OS. Operating system as an extended machine. So now we are going to talk why we called the operating system as an extended machine. Extended machine in the sense it's like a computer, another computer. Operating system is like a computer within the computer. Why we are calling like that? The architecture, instruction set, memory, organization, input, output, and bus structure of most computers at the machine language level is primitive and awkward to program. Yes, because we can hardly work with machine language 1011 something like this 00111. If here these are machine codes, but we can't easily understand them. Users does not want to involve with the programming hardware. Yes, if we need to type something, if I need to type letter A, if I am supposed to type 11110001, it's awkward, it's tiring, I don't like that. Instead, what the user want is simple. User requirements are very simple. Think about you guys. So imagine for attending an online lecture, you should walk 5 kilometers and climb up a tower to catch some signal. Then you should attend for the lecture for 2 hours and again get down and return back to home. If it is uh, if it is true, you are not going to participate for any online lectures because it's tiring, it's hard. So instead, you can log in with your mobile device, you can log in with your tablet, you can log in with your laptop. So it's fine. High level abstraction to deal with. High level language we have discussed. I think no, not yet. We'll discuss. So high level abstraction is high level interaction. It seems you can just it's like just speaking, right? You can give commands. Just give commands and the work will be done. Work will be done easily. In the case of disks, typical abstraction would be that the disk contains a collection of named files. So here they are talking about the hard disk. Here this is the hard disk and here we have several files. Each file can be opened, read and also edited, updated. The program that hides the truth about the hardware from the user and present a nice simple view of named files that can be read and written is the operating system. Yes, that's true. So think in the hard disk there are several sectors. So we'll see the anatomy of the hard disk quickly. Computer hard disk. So here we have several images. Anatomy of the computer. This one. So let me focus yourself here. So here hard disk is not a single disk. You have several. Here 1, 2, 3. We call them as platters. And here we have saved files. Here virtual representation. Saved file 1, 2, 3, 4. Likewise we have several files here on the disk. And we have this read write head also. This read write head will touch each and every sector and then that is going to transfer the data to the memory or the CPU. So we don't need to manually read these things. We can't do it. So the operating system will nicely handle that tiring task. That's the point. That's the point. So it will add numbers or names for this file. So let me open my file explorer. So here I have around 9 files, 9 items. So these 9 items are going to be saved on the disk like this, 9 scratches, 9 sectors, 1, 2, 3, 4 likewise. It is going to store here. So on the hard disk, they don't have any name, but here look, nicely named lecture 1, 0, likewise up to 7. And we also have file type. So on the hard disk, all the files are in the same type, but here nicely organized PDF file and text document. This is a text document. Here it says this is PDF, nicely organized. What has done this one? This is the job done by the operating system. So I think now you can understand how important is the operating system. The abstraction in the sense, the accessibility offered by the operating system is simpler and easier to use than that offered by the underlying hardware. If we need to deal with the hardware directly, this experience won't be smooth like this. So let me show you something. I think I have shown you this. So let me access this files using my CMD, right? Command prompt, right? So let me open my command prompt here. So you can press Control and L and type CMD. Or otherwise, you can do something like this. So let me ignore, right? So here in your any folder, go all the way here. Here you don't see anything here. Just click here, then type CMD. This will be highlighted. Then type CMD and press enter. What will happen? It will open this CMD. So if you see here, you can see the file path here up to here. Now here you should type dir and press enter. What is this? So let me make it side by side. So here new arrangements to unit test 2. So if I zoom in, here we have the same. Here we have the same. Here new arrangement, and unit test 2 is also here. Should there here unit test 2 PDF, right? So this is the command line interface, right? So let me go inside that folder where we were. So how to go that? You can use the cd command. So without the operating system, without the graphical user interface, this will be the scenario, right? So this was the scenario in the late computers. Late computers, they only have the terminal. They only had the terminal. So let me go to new arrangement. So here I have 9 files. So let me go to new arrangements in the here. So how to go? So here dir in the sense, these are folders, right? Dir directories in the folders, right? So let me go inside new arrangement, cd, then new hyphen arrangement, then press enter. Right, so here can you see the path has changed here. BABL IT 169 new arrangement. Not sure? Let me list the files dir and press enter. Boom. So here we are in the folder here. Altogether how many files? Here 9 files, 2 directories. 2 directories in the sense, here there may be hidden files. Anyway, 9 files. Here it's correct. 9 files. It's correct, right? So without the GUI operating system, graphical user interface, this will be your scenario. So today, when you need to join for this lecture or do something, you should type something here and try to join. But no video, no audio, nothing, right? So keep that in mind. So let's move on. Operating system as an extended machine. All right. So here, so application programs in the sense Word, PowerPoint, Excel. So they have beautiful interfaces. So these are like this, and operating system will deal with hardware, and hardware has ugly interfaces like that. So I have shown you some. It's not totally relevant, but it's something like that. Operating system as a resource manager. So first we have discussed operating system as an extended machine. So the main idea behind this is like this. Hardware has ugly interfaces. We can't directly easily deal with them. So the operating system will work with application software to make the user experience 100% brilliant. That's why I'm able to write like this. Otherwise, I can't select a pen here. I can't select the eraser here. I can't print it using this one. You should use manual things. You should go back to the file and try to print the document. This user interface exists because of the operating system. Without the operating system, this WhatsApp, File Explorer, web browsers can't run. So that's the main idea. So if someone asks a question, explain or elaborate the statement. Operating system is an extended machine. You should have, you could resonate it using a practical scenario. You can give practical scenarios. So let's move on. Operating system as a resource manager. So I have shown you several resources. If you go to the task manager, you can see how many resources it's managing. So it's, if you go to the performance, you can see it's managing the CPU, memory, disk. If I have many, it will manage more. Wi-Fi, GPU, likewise, right? So if I open this resource monitor, you can see more. Here it's monitoring disk, network, and here CPU usage. It's showing how many, how what use what and how much. If you go to the disk, here you can see what network, how much, what memory, what. Likewise, you can see several. And here also you have graphs, physical memory, physical memory in the sense RAM, available for disk activity. We have network. All right. A modern computer consists of one or more processors. It's true. Memories, disks, printers, and wide variety of other devices. The job of the operating system is to provide for an orderly and controlled allocation of all about devices among the various programs competing, right? So they are competing, right? They are like running, right? They are like running, right? So maybe this is what? This is Photoshop. This is Word, right? So operating system should think what should I give the priority, to whom should I give the priority here. So imagine there's a virus guard update, right? Virus guard update. So the computer has, it's hit by a virus, and Word is requesting the network. Word is requesting the network, but it's critical to give the network to the virus guard, virus software, antivirus software. So operating system will decide, no, we are not going to care Word. We'll allocate memory or the network for Word later. I will give the priority to this update. Then it will quickly update this one, right? So it will decide like that. So imagine you need to quickly open a video now, right? Now here this Microsoft Edge, this one consumes the RAM, right? So imagine you have 4 GB RAM, right? 4 GB RAM, 1 2 3 4 4 GB RAM, and here this browser is using 3 GB, and to open the video you need 4 GB, altogether 4 GB, but you only have 3 GB, 3 GB for this one, this browser, any browser. Then what the computer does, it will cut off this one, cut off this, and free this 3 GB space and allocate all the 4 GB for the video. Once you've done, what it will do, it will remove free 4 GB and it will again allocate 3 GB for the browser. It's like that. It's like that. It's doing a very hard job. Good job. So here if you go to the task manager again, here you can see some processes are marked like this. So let me show you whether it's there. I can show. Here notification manager for Adobe. It's what? It's suspended in the sense no resources are allocated for this. It's in the sleeping mode, so it's not consuming any resource. So let me show this one here. Search settings, I haven't even opened it, so it's sleep, in the sleep mode. And more, we maybe find more, right? So in your computers you can, in modern laptops mostly they are going to be in the power saving mode, right? Power saving mode. So you can see these things. So here it's running browser, it's running, nothing is sleep mode. And here we can see the power usage also. So it's regulating the power, even power in the sense current even here. This one is consuming the altogether 16. There are 16 tabs, very high, because the network connected and the Google Meet is streaming live streaming. You can hear and see me. All right, so let's continue. Operating system needs to keep track of who is using which resource. So it's like inventory management. Inventory management. So as I shown you, the OBS Studio is currently using the GPU. OBS using the GPU. So it will track it. Then if someone needs the GPU again, also it will tell no. OBS is using and it's critical. Why? Because I'm recording. And to grant resource request. So this is important to grant resource uh, request and to account for usage. So imagine when you connect your router to your computer, someone will anonymously consume your Wi-Fi quota. So sometimes it happens. So in that case, you can get a data usage report, right? So you can go to the settings here. So let me use a keyboard shortcut, or you can type network status. So if you go to this one, you can see the last consumed here Wi-Fi from last 30 days. It has consumed 24.77 GB. So if I go to data usage, you can see a little summary there. Here, Wi-Fi, choose a network, Ethernet also I have connected. So for past 30 days, 41 MB used by Brave, right? Likewise, so what the mostly consumed network is this one, right? So here, Brave browser 19 GB, system 3 GB, WhatsApp 640 MB. This is software. Any days likewise here, you can see a report. This is possible. Why? Because the system, operating system, is accounting on them. Add to mediate conflicting request. So imagine this camera here, the Google Meet also has the access for this camera, and the OBS Studio too. So now I am recording myself using the camera with the OBS Studio. Now when I turn on the camera on Google Meet, operating system will tell, hey, this camera is used by OBS Studio also. So please be careful, because if the OBS Studio loses the access, it can't record myself. And here, resource sharing. So we call this term technically as multiplexing. Resource sharing, multiplexing can be done in two ways. You can share one resource in two ways, in time and in space. We'll see what is it. In time multiplexing, resource sharing, different programs take turns to use resources. First one gets to use the resources, then another, and so on. So imagine you are waiting at the ATM queue, right? So you can't buy a ATM by your own. So you are in the queue, 1, 2, 3. So when the first person here used it and left, you can use it. Then the other one, likewise. So time multiplexing, different programs takes turns, and operating system determines who goes next and for how long, right? So it's like, so if you know some person in a dansal, so you can skip the queue. So we are maybe in the upcoming Vesak season, when you are waiting at the dansal, if you know someone from the organizing committee, he will ask you to come forward, so you can skip this queue. So this person is like the operating system, he has the authority. Space multiplexing, each program gets part of the resources. So it's like a bus, right? So in a bus, imagine you have three-piece seat. So if you are very fat, you will get the chance to use two seats. Otherwise, you should you only will get one seat, two seat, third one, right? You will only get one in the bus. You can't get the whole seat. So it's like this one, right? So think about the RAM, main memory in the sense RAM, right? So I have explained this example. So in my case, I have 12 GB. So maybe 4 GB is consumed by this OBS Studio 4 GB, and rest 8 GB for the web browser. Rest for 8 GB for the web browser, and like that. So main memory divided up among several running programs, and it is more efficient to hold several programs in memory at once rather than giving it whole to one program. It's effective, right? So if the OBS Studio is going to consume whole 12 GB RAM, then I need to run anything else. This is not possible. This is not possible. That's why it's giving only parts, and also it will make a reserved space for the system also. In any resource, there's a dedicated space for the system, because it's critical to have resources for the system. Functions of an operating system. So here they have listed memory management. Memory management in the sense managing the RAM or the primary memory, and the hard disk we can't get like that. It's a secondary storage, so we omit it. We are only considering about the RAM. Processor management, yes, CPUs and cores. Device management, we have discussed camera, sounds, keyboard. File management, already discussed. File management, creating files, reading files, updating files, and deleting files. We call this as CRUD. CRUD. Creating, reading, updating, and deleting. Security, obviously. So here Defender is running in the background. Windows security, no action needed. Defender. So when you install third-party software, it will play a warning tone, and it will tell this is malicious, remove this. Control over system performance. Yes. So when I power off the charger, so when I remove the charger, here let me show you. So if I remove the charger, is it working? Yes. So here it's connected. So if I remove the charger, this best performance will come to here. When the battery is going to finish, battery power is going to finish, so fell up to a certain level, it is come to somewhere here for the power saving mode. Now it's in the best performance. Likewise, it's controlling the performance. Job accounting. Yeah, you can't cheat with the operating system. So I have shown you the Wi-Fi consumption. So Brave browser is the one who has consumed the most of my data, and WhatsApp likewise. So it's accountable. Error detecting aids. So sometimes if this hardware or the software are not working, it's going to detect the errors. So it will send the reports to the Microsoft company. Sometimes it says this browser not responding, stop work, send a report, wait the program to wait the program to run, or terminate, something like this. So let me show that one also. Not responding, close the program or wait. So you will see something like this. Images. Here, this one. Close the program or wait for the program to respond. You will see such messages. Or kill it now. Coordinate between other software and users. Yes, obviously. Because when you come to Siva, you will see in computer apps there are several accounts. Admin account, user account, exam 1, exam 2, likewise you have several accounts. So controlling resources for each and every account. You have 4 passwords, 4 themes, different files, and file permissions also. Memory management continued. Main memory provides a fast storage that can be accessed directly by the CPU. It's true. For a program to be executed, it must in the main memory. Yes, here this is in the main memory. An operating system does the following activities for memory management. So let me save it, right? So now if I save, now it has been saved in the secondary storage also, but still it's loaded into the main memory. Otherwise I can't edit it, right? So you have seen when you save something on the hard disk, you can't edit it easily. Real time you can't edit. If you are editing it real time, it means it's in the main memory, the RAM. Keep track of primary memory. What part of it are in use by whom, what part is not. So I have shown you the example in the task manager. Multiprogramming. The OS decides which process will get memory, when and how much. Yes, it's true. Allocate and deallocate the memory. Just go through these things. These are practical things. It's like a manager in a company. He will assign tasks. He will give tasks according to your capability. If you are ill, he won't assign a heavy task. In multi-programming environment, the OS decides which processes gets the processor when and for how long. So we have discussed these things. This function is called scheduling. Right? Scheduling. It's like making a timetable or schedule. An operating system does the following activities for processor management. Keep track of processor and its status. Program responsible for this task is known as the traffic controller. It's like a traffic police. Allocates and deallocates the CPU CPU process same to a process. And device management. So this is a quick wrap up. Keep track of all devices, input output controller. So this we can call the operating system as the input output controller. IO means not that IO, input output. Decides which process gets the device when and for how long. Allocates, deallocates the device in most efficient manner. So if now I get a critical update, this one won't get the internet access. It will give the access for the update. File management. File system is normally organized into directories. So you have seen these directories. Simply directories means folders. Folders contain files, other directories. So files. Operating system does the following activities for file management. Keep track of information, location, users, status. So this collective system is called the file system. Decides who gets the resources, allocates and deallocates the resources. So for some files, have you seen, you can't get access for them. Why is that? Because operating system is blocking them. Other important activities. Security. So it will manage passwords, control over system performance, record delays between request for a service and response from the system. So it means it's error handling. So they will send reports for the Microsoft. Job accounting, keeping track of time and resources used. So this will track from 8:30 Sunday to around 10. My user, this user has used Microsoft Edge PDF for this time. How long? From this time to this time. Other important activities, error detecting, and we have production of trace in the sense is regarding to the updates. Coordinate between other software and users. Yes. So imagine you have a network driver, network device. So it's network device in the sense in the lab you have several computers. and there's a shared drive, D or something, right? So all of you, one will, here we have a teacher. The teacher will copy and paste the presentation into the D drive. So all the other students can go to their D drive and see this. So that's networked. And here in the operating system, we have two types. So there's a thing called shell. In computing, a shell is a user interface for accessing to a operating system's services. So there are two types of shells. We have the command line interface and the GUI. So this is GUI. So to access the settings in this Windows 10, what should I do? Just right click on the start and you can go to the settings. That's it. Settings. Here you have the settings here. Elegant GUI. You can click on the update here. Backed up, Windows update. If it is there, it's going to check. So the accounts are there. System. You can check the properties here. You can control all the things. But when it comes to the CLI, it's not like that. So let me open my CLI. So how to open the CLI? Here, press here. Then you should type CMD. Press the Windows button and you should type CMD. CMD. And here you go. Here you have it. This one. Not these things. Command prompt system. So if you go here, so this is what? This is the CMD or the command prompt. Yes. So previously I have shown you how to navigate here. So you can go to the E drive like this, right? So if I press dir, it will list the all the files here. How many files? 23 files, 51 directories. So 51 folders. So if I need to come outside from this one, I should type as I remember cd dot dot and press enter. Here now I am back at users. So if I need to come again cd dot dot. So you can try these things. Now I'm in the C drive. So if I need to go to the E drive, what to do? E colon. Now I'm in the E drive. So if I need to list down the things in the E drive, I should type dir. Dir. So here I have download this folder and this one. So let me go to this one. So for this one cd, and I should type first two letters, three letters of this folder and press tab. So it will automatically complete. Now I am in this one. So if I need to list what is inside here, it's not easy, right? So you should type dir and press enter. Here now it will show, right? So if I need to go to this, so I have folder for you guys. So where is it? This one, Siba peer tutor. So cd Siba and -p. Yes, okay. So let me quickly navigate dir. Then here I have BA lectures. So for that one cd BA hyphen lectures, right? And dir. So here I have a folder. Batch folder. So IT 160 fundamentals of computing. CD IT 160. It's not working, right? So in that case, right. So have you heard? Have you heard? Don't leave space in between file names. This is why. So you should type it exactly, because if you press the tab key, is it going to fetch? Sometimes no. If you have a space in between, it's not easy to pick, right? But it's picking now. IT60. So if I go here, now if I dir, here I have these things here. BABL IT 160, CFORM, likewise. So let me go there also. CD BABL IT 160. Sorry, BABL IT 160, and again dir. All right. So here I have these things, assignment and these folders, right? So you have seen these things, right? So that's how you navigate in a CLI, right? It's not easy. It's fast. It's not easy though. But you have both upsides and downsides in these things, right? So let me tell you. So let me quickly. So here, all right. So graphical user interface. It is type of user interface that allows user to interact with electronic devices through graphical icons and visual indicators. So we have the icons, search bars, uh, pictures, buttons in the CLI, GUI. Here, Windows 7 desktop. Here you have start button, task icon, likewise. Command line interface, you don't have such. Text-based interface that is used to operate system and will allow users to respond to visual prompts by typing single commands into the single interface. So here DOS, Linux, Unix. Then again we can classify the operating systems according to the type. Mobile, here Android, BlackBerry, Symbian, iOS, WebOS, and the newest one Huawei Harmony. Huawei Harmony OS. Harmony OS. Huawei, newest one. Then we have MS-DOS, in the sense it's a CLI one here, command line. So if someone asks for examples, you can type non-graphical command line interface. Non-graphical. Windows OS, it's graphical, commercial product. Here we have a clarification, differentiation between the GUI and the CLI. So DOS and Windows, it's a feature. GUI, DOS is text-based, it means CLI. This is graphic, image, and text-based. Input system, text is used as the basic input. Here you can use mouse and keyboard. Keyboard is also there, but in two keyboard is present, but you can't use the mouse. Multitasking, unable to run multiple programs, but Windows can. Storage size, highest amount of storage available was 2 GB, but here Windows it's unlimited now. Price, DOS is free, Windows is costly, means we should buy a license here. And what about Linux? Linux is an operating system mostly used in servers. So this is open source. Open source in the sense you don't need to pay, and you can even customize the code here. So imagine you need to add your picture onto the start button. You can't do it on Windows because it's proprietary and you are not allowed. But in Linux, if you have coding knowledge, you can change this logo to this your image. So here some examples: Ubuntu, Fedora, Debian. Having full access to the code helps bring about faster improvements and bug fixes. So if you are having a coding knowledge, you can fix some errors. Right. So that's about the operating system. So let me do a quick recap from the beginning. So let's be smart. So we'll ask the co-pilot to give the summarization. Right. So let me open it. So please give me the summary of this document in point form. Don't explain. So this is the summary. We have discussed about the operating system definition. So operating system is acting like a bridge between the user and the hardware. So why it is important? Because the user will interact with the application software, and the application software will interact with the operating system, and operating system is going to give the instructions for the necessary hardware. And also operating system has a nice interface and hardware has ugly interfaces, so we can't as users directly engage with the hardware. So in that case, operating system will help us to work through the application software. Examples of operating system: Windows, Linux, Mac OS, and Linux distributions. OS as an extended machine. So here we have discussed using an image. OS as a resource manager. So there are two ways. So this will manage the resources, the hardware and other options. So it will manage the time. It will allocate several time periods for several softwares, and it will also manage the space. Functions of an operating system. memory, processor, device, file management, security, performance control, job accounting, error detection, and software coordination. And we have discussed about several types of operating systems. Mobile, MS-DOS in the sense it's CLI, Windows is a GUI, and Linux both CLI and GUI. So this is the summary. So that's about this slide. So hope you have learned something out of this.